Children, taking some more problems from the exercise. See the third one. It says a wheel makes 360 revolutions in 1 minute. That means in 1 minute, the wheel is able to make 360 complete revolutions. So 360 times it is able to complete the revolutions in 1 minute. Now you have to tell through how many radians does it turn in 1 second. So we have to see in 1 second it has swept what measure of the angle, and we'll write that angle in terms of radians. Let us first see in 1 second how many revolutions it is making. As we know, in 1 minute, that means in 60 seconds it is taking complete 360 revolutions. That means in 1 second it is able to take 360 over 60, that is 6 revolutions. So in 1 minute, 1 second it is moving how many times? Completely 6 times it is taking complete revolutions. Now let us use it to get the angle which is covered in these many turns. Okay, now see. When a wheel makes 1 revolution, that means once it is completing 1 revolution, that means it is moving through 360 degree. That is the angle it covers in terms of degrees. In terms of radians, we can write it as 2 pi. So we know in 1 revolution, this is the angle made. And please see how many revolution it is taking in 1 second. That is what we have to find. So in 1 second it is taking 6 revolution. And in 1 revolution the angle made is 2 pi. So in 6 revolution it will become 6 into 2 pi. So number of radians turned by the wheel in 6 revolution or in 1 second, it will be 6 into 2 pi. That comes out to be 12 pi radians. So in 1 second it completed 6 revolutions, and in 1 revolution it was taking 2 pi radians. So in 6 revolution, obviously the angle became 12 pi radians. Then see the next one. In a circle of diameter 40 centimeter, the length of chord is 20 centimeter. Find the length of minor arc of the chord. So we can understand this through diagram. If the diameter is for 40, obviously the radius will be of 20 centimeters. So you can see OA, OB, they both are denoting the radius of the circle, and AB is the chord they are talking about, whose length is also 20 centimeter. So if you look at the triangle AOB, all the 3 sides are equal. OA, OB, AB, they all are of 20 centimeter. That means this is an equilateral triangle. Now if it is an equilateral triangle, it means the arc AB is making an angle of 60 degree at the center. Because we are dealing in terms of radians, so we'll convert degrees into radians. So AB is making angle of 60 degree or 60 into pi over 180. That comes out to be pi over 3 radians. So converting degrees into radians. So we know what is the angle made at the center. We know the radius. The arc length can be obtained using the relation between them. We know theta radians will be equal to L over R. That means L is equal to R theta. L is taken as the arc length AB. So L will be equal to R into theta, substituting which we get L is equal to 20, which is R, and theta is pi over 3. Replacing pi by 22 over 7, the arc length comes out to be 440 over 21 centimeter. Because it is not completely divisible, 440 by 21, you can write in decimal form up to, in approximation it can be written, or you can leave it like this. Now another example using the same result. It says if in 2 circles arc of same length. So there are 2 different circles. In both the circles we have to take arc with the same length. So see in the solution I have written, let L be the arc length in either cases. So in both the circles we will take arcs of equal length, which is L. Okay, so if in 2 circles arc of same length subtends angle 60 degree and 75 degree at the center. So in one circle the angle made at the center is 60 degree. In the other one the angle made at the center is 75 degree. Okay, now in this case we have to find the ratio of their radii. See, arc lengths are same, but the degree measures at the center are different. That means obviously their radii will be of different measures. So L is taken as the common arc length in both the cases. R1 and R2 can be there. radii like r1 in the first circle, r2 in the second circle. In the same way, suppose angles subtended at the center in both the cases are theta 1, theta 2. In the first one, we can name it as theta 1. In the second one, we can name it as theta 2. Because both the angles are in degrees, so I have first converted them into radians. Because this result, when we talk about this result, theta here is denoting angle in radians. So I have converted both into radians. Theta 1, the first angle was 60 degree. So in terms of radians, it will be 60 into pi over 180. So it becomes pi by 3 radians. Second angle was 75 degree. So it will be 75 into pi over 180, which comes out to be 5 pi by 12 radians. Now for both the cases, we will be using this result and simplifying the ratio of the radii. Now if using the first case, theta can be replaced by theta 1, which will be equal to L over R1. Now theta 1 is known to us, so we can substitute theta 1 here. Putting the value of theta 1, we get, which is pi over 3 is equal to L over R1. Let us keep it as the first equation. Then in second case, we can write theta 2 is equal to L over R2, which will come out to be 5 pi by 12 is equal to L over R2. So this is our second equation. Let us divide second by first or first by second, whichever way you want to. Dividing second by first, see what we get. It will be L over R2 getting divided by L over R1, which will be equal to 5 pi by 12 divided by pi by 3. So let us convert division into multiplication. For that, we will take reciprocal of the second term. Okay, so L over R2 into R1 over L, which will be equal to 5 pi by 12 into 3 by pi. So you can see L here gets eliminated. Pi we are able to cancel out. With 3 we can get rid of 12. We get 4 here. So the required ratio R1 over R2 comes out to be 5 by 4. So the required ratio of their radii is 5 by 4.